G'day everyone, what's up? Welcome back to the Pint Party Twitch channel. Gotta come up with a better intro than that. I feel like it should be something like the podcast. Like, welcome to, I don't know, I'm gonna have to think about that one. But today, we're back on the Exa train. This broke me, like, I'm not even kidding, like, after the last stream on Saturday, by the end of it, my brain was just like, it was just broken. Like, I was just completely rooted when I hit stop, because I was just like, my brain was dead afterwards. Like, I honestly just like blobbed out in front of the telly for the next few hours and like contemplated like taking a nap, but I was like too tired to even take a nap because that would have meant like getting up and going to bed. But I've had to think about it for the last couple of days. It's been sitting in the back of my brain. And this is something that I do when it comes to problem solving. Like, it doesn't matter if it's in a video game or if it's in any other part of my life. Like, if there's like a problem that I'm having trouble solving, I walk away from it. And I don't walk away from it forever, but like, I'll walk away from it and I'll go and do something else. And I'll let it kind of sit there in the back of my brain and kind of like, you know, give it one core of my CPU just to tick over. And let it do that kind of slowly and quietly. And every now and again, it comes up with an idea. It's like, hey, how about this? Like, how about this? How about that? How about the other thing? And so I've had an idea about how to beat this. And I think my problem was last time that I think I was on the right track, first of all. I think I was on the right track with having like one Exa that just does the password cracking. Like, that's all good. You can see here I've only slightly modified the code. I've like just basically commented out where it says copy what's in the X register to M, just so that this can work on its own for now, but I can like uncomment that and put it back into the code when I'm ready to like have it talk to other Exas. And I wanted to have it talk to other Exas. And I think having it set to local is also the way to go. Because I think I still need a third Exa to like receive the message in the host. So we're going to have our two other Exas. So Exba is going to replicate Exas to go in here and grab the file and like communicate over to Exa. But the problem was that whole process of replicating and trying to break in was all happening way too fast and without any kind of like validation. And I think that was the real problem. So I think what needs to happen is every time, instead of just having Exba operate independently and just pump out the X's to try and like and just like throw themselves at the thing, I think Exba should get the password. So it goes through this process and copies the X to M, and then it receives that code, and then it creates an Exa with that and gives it that code and tells it to try that code. And I think that's going to slow that whole process down to, instead of just creating them like every cycle, which means that there'll be one created here, one created here. So you have three, but just before we've even sent out a password, which means you're making two Exas that are completely useless and are just no good for anybody. Except to like take up memory and clog the whole thing up and then clean up a big pain in the butt later on. So I think the trick is going to be like getting it to communicate with just Exba, who then creates the new Exa with that password and then tries it. Now, how to do cleanup after the fact, after that, I think is a little bit more difficult, but not too difficult. I think what I can do is the replicated Exa, if it has the right code, mind you. If it doesn't have the right code, it just blows itself up anyway. So like that kind of like whole process just takes care of itself. But once it has the right password, remember, once we've unlocked the thing, it just stays open no matter what else we throw into this register. And this is going to keep going all the way through every single possible combination. Oh, wait a minute. I could slow the entire process down, actually, and get rid of an Exa in the process. I could have that at every combination, just have this Exa replicate the new Exa and go and try it. And if it works, and this one can wait until it gets a signal back saying, yeah, dude, like, we totally got it done. No, but then if it doesn't work, it'll just sit there and hang. And no, actually, no, we're not going to do that because that'll just cause this to freeze up. No, I think what we're going to do is we're going to stick with the plan that I kind of came into this with. We're going to send an exit in. It's going to do all of its stuff with exit to create the new file here, which is totally fine, and say here's the right password and here's the what's it called, the code thing, the RDK ID. And then I think what I'll have it do is I'll have it link out and do a kill command and basically like shoot the Exba in the head, and that will stop this from creating new exits. It will also cause this to freeze though, because it won't have anything to communicate with, which is a problem. So I wonder if there's a way to lock this again. Like, once it's unlocked, can you lock it again? Because if I could just lock it again, once I've got the password, like, you know, it's just like a phone. Like, can I like unlock it and then lock it again? Like, can I just do that like a phone? Like, that would kind of solve that problem. One exit goes in, gets the file, comes out, you know, shuts the door behind itself, and all the other ones just like slam themselves against the door again. That might work. Hey, man, what's up? How do I pronounce your name? Is it Akronoskos? Or Akronoskos? Is it Greek? Is it Kronoskos? Or is it Klingon? It might be Klingon. My Klingonese is not great. Some might even say it's almost non-existent. But let's write some code. Okay, so we've got a plan. We've got a game plan. Let's list out some code. Okay, so Exba, which is going to do all the replication. Let's set its M register to local because we only want it to talk to our Exa. Oh, okay, it's just a garbage combination of letters. Okay, well, you've got Chronos in there, which is like the Greek word for time. So that's what made me think that like you had. Well, I don't know if it's modern Greek or ancient Greek, but like Chronos means time. And then if you spell it differently, it's also the name of the Klingon homeworld, but that's some like hardcore nerd humor. But whatever, I'm playing a hardcore nerd game, sue me. Okay, but let's get this going. So link 800. So once it's in there, then we're going to start its loop. So let's unnote this because we're going to use these. It's going to wait for these to do its thing. So we're going to do this and we're going to do this. Okay. So, then we need to make a loop. So we're going to mark a rep loop. So this is our replicator loop. We are going to copy what's in the M register to the X register. And then we're going to create an Exa. We probably need a test, don't we? Do need some kind of a test. It could blow itself up at 999. I pronounce it with 2 long O's. Oh, okay. Yeah, so it's alright, so it's Kronoskos, like, yeah, Kronoskos or something. Yeah. I think Kronos is a good name. Like, it's a very, very good name. It means time. It's a good name. It's got a real, like, Time Lordy, you know, Doctor Who vibe. I'm pretty good with. I think that's a really good name. You know, or Kronoskos, you know, Kronoskos, like, why you call time? Cos. Something like that. Okay, so we're going to replicate, and then, how does replicate work? I think you just go repl, and then you just create, I think then you just list out, where where you want it to jump to, I think, don't you? Yeah, with its mark. Yeah. Okay. This is why we have the reference guide open. I've got both the manuals open, both issues that we have access to right now open, for this exact reason. Oh, I'm glad you like it. I hereby doth the Kronoskos with all the powers vested in me by the internet people. All right, so we'll need to create a mark for that. It can sit there and be like and complain for a while. So this is our what should we call this? A crack loop? A crack loop? Yeah, why not? That's a bit weird. No, not it's crack loop. Now we still need a way to validate if we jump to this loop. Well, actually, we need an end loop as well, because I think that's the best way to kind of do that. Halt. So basically, what I reckon is we tie this to this. So like when this reaches 999, it'll send that. It's going to send it off before it does its check. Oh no! It's going to add one to X before it tests. So it'll never do. Oh. That's actually... Oh, no, because if it's greater than... No, if it's greater than. So when it hits 1,000, it stops. So it will check for 999. So, yeah. What I'm going to do is when it receives 99... After it's done its replication, it's going to test if X is equal to 999, which means we've reached the end of all of our possible combinations. And if that's true, jump to the end. Otherwise, it's just going to jump back into the rep loop. So what that's going to do is it means that once this stops, this is going to stop as well, because the last instruction this is ever going to send... No. Ooh. Well, we can move some stuff around. Because... Well, once it's sent 999, it's going to want to copy something over into the X. It's going to send something over to the X register anyway. Well, then we can just check if it equals 1,000. That just... I mean, why mess with this code that's really good and works when all we have to do is just increase this value by, like, literally by 1, and it's like, fine, it now works, it's fine. Because it'll send over 1,000. Well, no, it'll send 999... Won't it? No, it will. Yeah. So, okay, so when it reaches 999, it'll send that over, go to 1,000. Oh, wait, no, so it will. Yeah, so the last number it will send is 999. Now that I'm looking at it. Oh, screw it. We'll test it. If it doesn't work, we know what the fix is. Okay, so I think that's actually going to work better, because before, I just had it just doing this just like without any checks, it just went buck wild. It was just like, make all the exes, and it went absolutely bonkers. And that was just, I mean, that's just bad programming. You should always, whenever you write a loop, you should have a way to break out of a loop. And you should have conditionals for your loop. So that's what screwed me up, was bad programming. Good craftsman never blames his tools. Okay, so now that we've got the we now need to do the replication step. Which is, again, that just turns into an 800. It just link 800. And then that'll probably just die a bunch until it reaches 473. And I can't remember what the number for the... I can't remember what the file number is. That's fine. Here's what we'll do. Here is what we will do. We're just gonna jump through to... I mean, let's just jump through to here, and we can pause it. Okay, so we got to 100. Oh wait, hold on. Oh right, yes, okay, because we did the first time it went through. Okay, so we're just gonna... Yeah. Is there a way to speed this up, though? Actually, I think there is, if I just do that. Okay, and then we're just going to run this through. And they're all going to blow themselves up anyway. Until we reach 473 for this first run. So, wow. Okay, I honestly thought this might go a little faster. Oh, whatever, we're at 200, it's fine. Oh, whoops. Ah, doesn't matter. Screw it. Okay, so file 199 is the one we want. Okay. So it's going to link 800. Grab 199. Ooh, actually, first thing it's going to do, before it does anything else, is this is going to set its mode to global. So the reason why I'm going to do this... No, because it's not communicating. It's not communicating at this point. It doesn't care. It literally doesn't care. No, that's fine. No. Don't confuse the order of operations, John. Okay, so we're gonna link 800, we're gonna grab 99, then we're gonna go mode, because remember, it's gonna replicate as a local node, if I'm not mistaken. Yeah. So it creates X0. which is set to local. Yeah. So we need to set that to global so that it can talk to Exa, who's going to like, okay, I've got a file here. I'm ready to like, you know, it's our scribe Exa. I couldn't. Yeah, nah. This is the easiest way to do it. I was gonna say I could get that replicated Exa to like literally do everything, and then have it not be a problem. But like, why? Because I would have to then create the file, write in the code, drop the file, pick up the other file, copy the thing, drop the thing, pick like it's just that's just way more steps than just like broadcasting. Hey, here's what I want. I got, you know, my name is Exa, and I'm here to say, I've got codes every day. I don't know. I don't know how Exas rap. So it'll do that. It'll do that, and then it'll just copy whatever's in its X registry, which will be that password. It's going to copy that over the M registry. Then it's going to copy the first thing in its F, which it's just grabbed. It's going to copy that over. Ooh, that's right. Wait a minute. I think it does. I don't think it matters. I think because that's the file we need to have down the bottom there. New 473. Yeah. Oh, yeah. Yes. That's it. Oh my god, Ex's rap using jump statements. Yes. Oh. Yeah, they're big fans of Run DMC. I'm pretty sure that's them. Oh my god. I suck at music. Everybody knows this. I'm bad. My music knowledge is really bad. Past, like, 1999. Or if it's outside of the synthwave genre, I really don't know. But yes, they jump around. Oh my god. I should. I'm gonna make that album cover because that would be funny as. Yeah. Okay. I might do that and post it on our Instagram. If you follow us on Instagram at Pint Party, I promise I'm gonna work on that sometime this week. Oh my god, that's gonna be funny. Yeah, I'm gonna make that album cover. Alright, so the answer file should read 473 RDK or whatever. But do we need to have it swizzed out like that? Which I'm happy to do. That's really no problem. Because I now know how Swizz works. That was like the biggest problem last time, was figuring that out. I'm now very confident with Swizz. So we can just Swizz it. You know, I'm gonna Swizz it out just to flex. Just to be like, just to show my confidence in my swizzing skills. I'm gonna make it Swizz. Because yeah, because like I'm just gonna flex because I can do it. Just cause. So the first thing we want to send over is the 100. So we're gonna Swizz, and we're gonna go. So how it's Swizz, and then it's the mask, and then you write. Yeah. So 003. We're gonna send that to M, and then we're gonna. Wait, what's it saying? Why is that freaking out? What's wrong with that? That's right. What do you want? Invalid register? What the heck are you talking about? That ain't an invalid register. That's totally valid. Alright, screw it. No, you know what we'll do? We'll just do the Swizz. We'll do the Swizz on Exa. Exa can do the Swizz. So that's fine. If you're gonna be like that about it, that's fine. Exa is going to make a file, and then it can just sit here and wait for an instruction. So it'll copy M to X because it's going to receive the first. It's going to receive that instruction. Which is this instruction here, which is the password. Then it'll do the swizzing. It'll swizz, and then it'll copy that to F. Oh no, that's right. We need to swizz X, and then. Oh right, no. I see what I've done wrong. So where are you swizz? It's like addition and stuff. I forgot to add in my. Yeah, okay. So I could have done it in Xbird to flex, but whatever. We'll do it here. Swizz X 003 to F. Yeah, it was missing that. It's read register, not the write register was the problem. And then we just do that 2 more times. So I'm just gonna write it out like this, kind of like writing out, you know, like Bart on the chalkboard style. 002, 001 to F, to F, like that. So it's going to do that, and then it's going to copy what's in the M register to F, and because that'll be the RDK ID, because that'll be the second thing that comes over, and then that'll just hold. Like, that's done. The only problem is cleanup. So once it's able to successfully go through, I suppose we want to make sure that, well, anything that's coming through while this is happening is just going to get blown up, because if it can't grab anything, that's a file exception error of what's it called? Hang on, it talks about it. Let's see. Invalid file access. Right. So if you're looking for a specific file, which, once we're grabbed the file and we're busy writing the file, anybody that's coming in the meantime is just going to go boom, because that file is already being used by another exa, and they're not going to like fight over that file and be like, I want the file. Like, no, it'll just go, oh, you've got the file. Okay. And just blow itself up. So that is all good for that point. But, well, we can just keep hold of it and just let them all blow themselves up. But then we want to make sure that we still need cleanup to happen. Well, we could basically make a counter, a timer, and just have it kind of count itself up from where it is. So, like, let's say for the first test, let's say it's at 500, and the code is 500. So then we just say, okay, double that value, or no, set its value to, what's an equation we can do that always equals, oh, all right, okay. We tell it to subtract whatever the value is in X from 1000 and write that to X, and that's how long we've got to wait until we halt. And everything else will blow itself up. And remember, once this reaches 999, it'll blow itself up and stop making more, so it will be empty. So this will be last one out, turn off the lights. Yes. Okay. So once it's done all of that, it will then we need it. Then we kind of need a. Well, do we need a loop? Yeah, we do. We need a loop because we need it to like subtract. So let's mark, and we'll call this a kill loop, because, well, let's just call it kill. No, I don't. It's not really a kill. It's a wait loop. It's a wait. That's what it is, because it's just gonna sit there and wait. It's gonna sit there and twiddle its little itty bitty extra thumbs. So that's what it's gonna do. And the way it's going to do that is it's going to subtract. Oh, wait a minute, because it's subtracting from X. That's okay. No. We're going to temporarily use our T register. So we're going to copy. Oh, wait. That should actually happen up here. We should do some setup up here, because it can do it up here. So we're going to copy 1000 to the T register. Then we're going to subtract. Subtract from T X and write that to X. Yes. And then it can go into its wait loop. Excellent. Yeah, that's good. Yeah, that'll work. Okay, and then it's just going to test if X is equal to 0. Maybe should we make it 1,000? Yeah. That guarantees it. Actually, because that means it means one cycle after this has blown itself up and Exba's blown itself up, its clone will then blow itself up like next. It'll go in that order, which is what we want it to do, to ensure that everything else has gone before that. Okay, test if X is equal to 0. If it's false, it's just going to jump into the wait loop. Yes. And then otherwise it's going to fall through when it's true, which goes to the end, and it'll halt, and it'll just go and automatically drop its file, so we don't need it to drop its file. I reckon that'll work. Let's try it. Okay, so they're all blowing themselves up, happy as a clam. And our password cracker is working, and it's receiving files constantly, which is really, really nice. And you can see already like an immediate difference. We're not just like filling this up with exes constantly. We're only making exes that we need as we need them, which is much, much cleaner code. Way nicer. So yeah, this is way, way nicer. And I also had a thought the other night, like, because I saw obviously the great algorithms of the internet know I'm playing Exapunks, and so YouTube has been recommending me Exapunks videos. And one of them was like why Exapunks is good for getting people into programming. And I thought about it and I was like, yeah, this is actually a really great, like if you were trying to understand or teach someone how object-oriented programming works, get them to play Exapunks, because this is object-oriented programming. Like, it really is. We've got all of our code kind of like separated out and running independently and code processing and stuff like that. Yeah, it's great. Okay, here we go. So we're coming up on our password, which is 473 for this first test. And that's really all I care about right now is this first test. Can we get through this first test with a test 1 complete? Because we haven't even done that yet. So what I'm hoping is going to happen is once it gets the password, that exa that gets through is going to grab the file, write to exa. Yep, wrote it to exa. And then all the others are going to blow up because this is now waiting. And XB473. Oh, look at that. It's even, yeah, because they're all numbered. Sweet. So now it's waiting as it counts. Oh, that's going to count forever. Herpa-derpa-der. Yeah, herpa-der, because we didn't put in our countdown. So I am actually just going to add one for safety. No, I'm not. If we need to add one for safety later, we'll do it. That's no big drama. So we're going to subtract from x 1 and write that back to x. Then we're going to test if x equals 0, and then we're going to jump into that loop again. But we know that we get the file exception error. That's actually a really good point. I should actually do that. Yeah. Okay, here we go. So now, are we subtracting? We are, and we're looping. And everything else is getting built, and it goes file exception error, and it blows itself up. Okay. So now we're going to run through this and see if it gets to... Well, actually, what am I doing? Let's just go all the way to here. Okay, here we go. So it's counted to 0. Oh, but these haven't blown themselves up yet. Wait. So what's... Uh-oh. Because this counter is happening faster. Yeah, so it's blowing itself up, and that's going to come through and grab a file and then freeze. Okay. Right. So maybe we need to wait for so many cycles. Actually, yeah, how many cycles does stuff take? Because yeah, because I think that's what we've got to kind of like multiply by just to make sure we get our timing right. Well, actually, let's get to here. So it's going to get to here, and where are we at in our loop? We're at 2. Okay. So it goes 1 cycle. Oh, right. Yeah, no. We need to get to, not to that one. We need to get to, like, basically this one. Okay. So now it's created 1, 2. So 1, 2, 3. Actually, it should be on here. So 3. No. What's this one? What's 474? Oh, right. File ID not found, and then it blows itself up. So 3. Okay. So we actually need to subtract from 3,000. Because it's not, yeah, because that's how many actual it's like that whole loop of working up is actually taking, yeah, of course it is. Yeah, that makes sense. Okay. That's okay. That's an easy fix. We just copy 3000 of T and we do everything our same. That should make all of that work. Okay. So, like, let's get over. And I just want to make sure that, like, so that's number 473, which now has 2,527. And now it's going to wait that amount of time. And hopefully everything else cleans itself up by the time it's ready to halt. No. Oh, yeah, that's 999. They all blow themselves up. And then, is it still going? Oh, wow. It is still going. Okay. That's just a lot of useless cycles now at this point. Okay. But it's just a matter of dialing that in now. Like, that's all we got to do is just really, it's just sort of like, oh, I know what we got to do. Because we got to triple... So what if... So we know that like basically the amount of time we're going to wait is based on cycles, not on how many times like this code's going to execute, because that's not all happening. That's each one of these is a cycle, and this is all happening on, that's one cycle, that's another cycle. So this needs to happen, and that's all going to happen on 3 cycles. Oh boy, there's a lot of 3s that we need to kind of divide by. Well, wait a minute. What if we just subtract that and then divide x by 3 and write that back to x? Maybe that gives us our true number. Maybe. I don't know. But let's try it. Let's see what happens. We'll let it run, and then it should open up its, yep, number 473. Oh, which then blew itself up. Oh, and we've still got... Yeah, okay, so that's not quite the right answer. Okay, cool. That's fine. Maybe what we'll do is maybe we start with 1,000 and then we multiply that instead. Is it multiply? How do I multiply? I've never actually done a multiply before, so like... oh, it is. It's, yeah, multiply. Okay. So let's do this, and we'll multiply it by 3. Let's see what that does. Ooh, we're getting closer. We are getting way closer. That was way... Look at that. Now we're at 905 when we have the problem. So that's actually like... Okay, alright. So this is just tweaks now. This is just tweaks. We know what the solution is. We just got to tweak it. Just a few more tweaks and then we can beat Drift King. Yeah, there you go. How's that? Tokyo Drift reference. That's a super obscure one. I don't think anybody would remember that line. Alright, so... Got a maybe... I think this is maybe all working. What if we move these around? What if we do the multiple... Well, see, but then why multiply? Like, just start with a 3,000. That, yeah, okay. That would essentially be starting with 3,000. Is that... I can just comment out like that. Oh, yes, that's what I'm going to do that. So we're just going to start with 3,000. And we'll see what that does. Because it should, if I'm correct, it'll do the exact same thing. And if it does the exact same thing, then we can basically get rid of the multiply line and we'll try something else. So 700, 800, 900. No, that's kind of working. They're all blowing themselves up. And then what do we got left? 600. Yeah, now, okay, so now we're back to 600 cycles. Maybe our initial number of 3,000 is wrong. That might be it. So hang on. So let's go into our loop and let's check how long this loop takes. So 1, 2, 3, 4. 1, so 5, 6, 7, 8. So it's actually 8. So and then it'll start itself all over again. So maybe if we start, so let's start with 1,000, and let's bring back our multiplier, and instead of multiplying by 3, let's multiply by 8. Hopefully we don't go over 9,999, because that would suck. Okay, and then let's do a test. Okay. So that's worked. It's working its way down. And it's still got, whoa, 2,000 cycles left. Okay. Yeah. So multiplying by 8 is a bad idea. What if we just straight doubled it? What if we just straight doubled the number instead? Just to try and, like, we're just trying to bring that number in. It isn't, no, you're absolutely right. It isn't as low level as this, but because this has a really nice, like, difficulty curve, and it does have a really good, like, I mean, it's got a good manual and stuff in it, and then there's heaps of resources online. Like, I think I mean, the game basically helps you along. So instead of, like, it probably doesn't. I don't think it translates skill-wise at all. It's just about getting people used to, like, thinking programmatically. And giving people an understanding of object-oriented programming, which makes, when you then start to learn an actual language, like, let's say C#, because, you know, people want to make games in Unity, that language becomes way less scary because you already have an idea of how object-oriented programming works. Like, that was my biggest problem for a long time. I had no idea how object-oriented programming worked, and it really screwed me over with things like Java and stuff like that. Okay. Oh, wait. Hang on a minute. Why did that blow itself up? Hold on. I thought we solved this problem. Oh, because multiplying by 2 is no bueno. Is that the problem? So we're gonna go 473. Maybe instead of subtraction, maybe we go add. What if we do this? So we copy 1,000 to T. Hang on a minute. What if we then? I'm gonna rewrite this, because I think what we need to do is we need to do some more work on the password kind of number side, I think. Wait, add X to T. From X, add T, write that to. May as well write that to X, actually. Yeah. Okay. So we're going to add our X value to our T value, write that into our X value. And then we're going to multiply that. What's in the X value by 3. And write that back to X. Maybe that'll work a bit better. Maybe it's just about just dialing in that number. So instead of subtracting, we add. Maybe that'll work a bit better. I mean, it kind of does, but we still got 2,000 cycles left. Maybe instead of getting a set number, maybe we just do a straight 3,000 cycles. Maybe that is the answer. Copy 3,000 instead of copying it to T, we'll just copy it to X, because we don't need the password anymore. Because once we've done it, yeah. Maybe let's try that. Maybe I have a tendency to over-engineer these puzzles, so maybe I'm just over-engineering it. I might be overthinking it. So that gets to 999, and then we're down to 1,000. So we're actually a lot closer. So we're only over by 1,000. So let's bring that down to 2,000 then. Yeah. Okay. So we're getting real close now. Technically, this solution works. Like, I'm just trying to, like, refine it, because it's just, there's so many unnecessary cycles, and it's such an easy fix that there's no reason not to refine it and try and get a better score. Like, that would just be stupid. Okay. So we get to here, and then what are we at left? 73. See, now that's acceptable. I'm okay with that. Yeah, and then it's just gonna run through, and then it'll blow itself up. Yeah, there we go. Oh my god. Yeah. Yeah, that's right. I remember. So after you brought up using Swizz, I found a solution that takes somewhere around 5,000 cycles. I don't know how many cycles I just spent doing that. Let's see. What did I? Wow, I'm already at 7,000 cycles, and we're like halfway through a test. So yeah, okay, you've got a way more efficient solution. That's cool. Alrighty. But the test works. So now, oh, we got a problem. We got a problem. Why is that getting frozen? Oh dear, on test 4. What's going on test 4 that's causing a problem? Well, our problem is in here, so let's go to our wait loop. See what's going on. Okay, so 200. Oh, yeah. Okay. Maybe we should set it to the maximum, just to absolutely guarantee. Yeah. I have that exact same problem. Like, I overthink these puzzles. Absolutely. That's always my problem. So what's that doing? So that's going to go down. Okay, well, I'm just going to let that now run. And so far it's doing all right, but it looks like, yeah, it's going to run out of cycles before. Yeah. So maybe we multiply. Maybe Swizz is the solution again. Like, maybe we Swizz our just to get our multiplier. No, that won't work, because if the answer is 0, then it multiplies by 0 and nothing changes and we have a problem. So maybe we use a divider. Maybe we start at 9,999 and then just divide it. Maybe, but I just want to see what's so 900, 800. Oh, so it got to. Oh, I didn't see where it got to. All right, so let's try and move this along again. So XB 221. I want to see it get to this point. 2, 1, 0. So so what's it sending over? 768. Okay, right. So yeah, a few more tweaks. So what if? Hang on. So that's what I'm thinking. Like, if I just set this to 9999, like that's guaranteed to work. But instead of copying that into X, what I'm going to do is I'm going to copy that into the T register, and then we're going to work on it. So we're gonna keep our password, because we're gonna Swizz from the X register 003. We're gonna take that and write that to X, and then we're going to divide from T the value of X and write that into X. Maybe that'll work. Let's go to here and find out. Okay. Sends that over, and then it starts with 999. And then it goes divide, and then it starts moving through. Okay, let's see XB 221. Let's see where it gets to when it runs out of cycles. So it's halting. Oh, this is halting long before this halts. But we've cut down the amount we're going to halt by a heap. And then it's just going to do its thing for another 2,000 cycles. Alright, I want to restart. I want to get to here and see if there's anybody. Actually, no. Wait. Yes. Okay. So it's doing that, and while that's all happening, it's still creating exes. Yeah. Okay. Because I was thinking we could just go out, and just like go on, and just have this exa do the killing, which is kind of the original idea. But if it did that, there'd be another exa that just jumps in here right at that same time, and that would be bad. So I think this is kind of the best way to do it. But instead of maybe 9999, maybe we just set this to 9000, just to try and lower that value. And let's see it gets to this point again. So it gets to here, and then that's that exa, 221, and I want to see it count through and see if it works. So 2, 1, 199, and it's at 1650. Okay, so that's a lot closer. So I think 9000 is kind of where it is kind of the sweet spot, I think, because we need to know, because that's a 222, so we want to make sure that if say the password is like say 100 or less, that it still works, and I think 9000 is kind of going to guarantee that. Yeah. 5. Oh. 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 Nope. 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 It didn't work. It didn't work. Okay. In test 10, it broke. Okay, so maybe we do set it to its maximum value. Maybe we set it to 9999 and run the test. Let's see if it works now. No, it does not. Okay, it's still getting stuck. Okay. All right, then I want to get to here and see what happens in this test. So we're here. Okay. Oh, because the answer was 2002. Ooh. Yep. They can't divide by 0. Yep. Yep. Okay. So having the division is dangerous, so we're going to get rid of that then. We're just going to do straight countdowns. Well, no, we can do a subtract. We can still subtract. We can still subtract, even because you can still subtract 0, because like 100 subtract 0 is still 100. It's fine. It should leave it alone. So if we subtract x from t and write that into x, that should work. Just to get rid of like, yeah, that value. But I want to make sure that works all the way up to test 10. Actually, it should. Yeah, no, but it's not. It's not. Why is it not? Oh, no, it is. Nope. Nope. We got a... Oh, no. We got a minus 9999 for some reason. Okay. Oh! Whoops. It subtracts from t the value of x and write that to x. I got my registers confused. Oh. Yep. No. Okay, so now that's running. But it's running a heap of cycles. It's like 20-odd thousand cycles. Okay, we got past test 10 though. Okay. That's kind of good. But this is probably now going to happen really slow. I mean, this is as fast as I can make it. Leaving no trace. So, that's kind of the best we can do. I think that was what they wanted you to do though. They wanted you to like take care of exes, like, because I think it even, no, it doesn't say it here. Okay, so I thought it would I thought it was this one that said have a look at this exemption error thing in the manual. Because one of them did that. Because one of them, it was basically giving you, the clue was to use exemption errors. It might have been the one before this actually. So maybe this is the one that assumes that you now know that concept and you can like apply it in another way. Okay. But we seem to be working. Yeah. 75, 76. It's now, this is like, oh boy, it is like not efficient. It's not that efficient, but it works. It kind of guarantees to work, which is nice. Yep. Yeah, it's just not super efficient, but that's okay. I haven't been writing efficient code. I write a code that gets the job done. Is it the most efficient? No, but it gets it done. And I mean, like, a lot of programming is like that. The size of your solution exceeds the size limit for this task. Ah, so I don't get to see my score. Yeah, okay, fine. So let's see what we get. Yeah, I know, right? Yes, we got the level done. That's true. Yes. All right. Oh boy, here we go. So what's Ember want? So Gast used to work at a game studio. Everyone needs to make a living. I don't know. What's wrong with working at a game studio? It's fine. Yeah, he was a programmer. I think. Yeah. I wonder what that was like. I bet it was fun while it lasted. Figuring out how to push a console to its limits. Making something that brings joy to people. Yeah, I can see that. I really hope she doesn't. What we're trying to avoid. I've never, like I said, I've never finished this game, so I have no idea how the plot's going to turn out. But like, I have very strong suspicions that Ember's going to go full like Cyberman and be like, humans need an upgrade, and like the best way to do that is to like push their their bodies to their limits or something, and like then we end up with like hey, let's conquer all the humans. Oh, here we go, more chat. Just got issue 2. Hell yeah, can't wait to dig in. I like that it's on paper. It's quaint and oldie-timey. Oof, way to make me feel old, Mutex. Mutex does a cheeky smile. Plastered shakes his cane at the kids. Get off my lawn! Uncle Plastered getting riled up over here. Nice. Okay, and then this is, create your own games for the Redshift, which is an optional, which we're not going to do. Well, I'll take a look at it, but I'm not going to muck with it too much. You're really going to make a game with this? Why? I'm not offering a reward for it. Making something is its own reward. Oh, it's one of those intangible things. A sense of accomplishment? Self-actualization? I'm not good at abstract concepts. I'll have to observe you closely. Well, I'm not going to do much. I'm just going to open it up and take a look at it, and then I'm probably going to quit. So this is like the Redshift development kit, and there's a whole, like, the issue 2 of the manual is like completely dedicated to it. It's like, here's how you do frame synchronization and detect collision and colors and all sorts of crazy stuff. But this is the thing we were trying to break into the entire time, which is why I like to have this open. But there are like there are people who like legitimately spend hours like just developing games purely for this. And as you can see here, we've got more registers as well. There's a G register and a C register. And G is graphics, so you can write, that's how you make little graphics on the screen and stuff. And then I don't know what the C register does. I'd have to read the manual to like find out. But yeah, basically that's what people do. And you can like you can mess with this and press buttons, and like this is how you like work with your how you play your game, is that you just physically press the physical buttons on the thing. I know somebody who like wrote yeah. Like you can download other people's Redshift games and like download them to your computer, and I think you can do that over Steam Workshop. And yeah, like I remember one of the ones I saw is somebody was like, "Hey, I made the Solitaire game from Shenzhen.io and brought it and like basically ported it to the Redshift," and I thought, like, oh, that's really cool. So yeah, you can make all sorts of crazy stuff. Like people have made like Galaga and stuff like that. It's really cool, but we're not gonna muck with that because like doing all that homebrew like is just it doesn't advance the plot. And I think you might get an achievement for it, but I'm not that big of an achievement hunter. All right, so what's our next meeting with? Oh, it's a cutscene with Ember. Oh, okay. Continue the discussion of morality with Ember 2. Ooh, okay, okay. Let's wade into that. Let's wade into that can of worms.
Okay, I have a real question to ask you.
Shoot.
Say there's a trolley on a track heading toward 5 people.
Mm-hmm.
3 of those 5 people are vegetarians.
Right. Go on.
There's a switch you can throw that will shut down a meatpacking facility that is located down the road.
Okay.
Unfortunately, the switch will also prevent the train from stopping because... Wait, I may have reversed something. Recalibrating. There are too many variables here. Okay, let's return to this later. I need more data first, and I need more processing power.
Right. Okay. You ever think about how society has advanced? No. Has it? Like how far we came in just the last 100 years. And things will only get faster. Technology is accelerating, but life still sucks. Only if you believe it does. People still suck. Ha. Alright, so yeah, that was just sort of like a little bit of filler. I think the concept is like Ember is still struggling with the idea of abstract thought, because like that problem requires a little bit of abstract thought. But it's also like a problem that we're actively teaching AI right now. Like a lot of like self-driving car manufacturers or people who are interested in self-driving cars are like dealing with like how do you teach a self-driving car to deal with the morality of that problem? Because like let's say it ends up in a car accident, like who does it protect? Does it protect the person inside the car or the people outside of the car? You know, does it protect its owner or does it protect the people outside the car? I personally fall under the opinion that it should protect the person inside the car. But like, yeah, that's a whole moral quandary that we're trying to like wrestle with and then trying to figure out how to teach that to cars and stuff. Digital library project. All right, so what are we breaking into this time? Copy requested books on various topics from a digital library. Okay, all right, so we're going to go full Abby Hoffman here. We're going to steal books. Got it. Time for some research. Human physiology, human morality. Yep, as you do. Yeah, I guess so. Wait, am I really that predictable? I'll have to change things up soon. Let's get those books. Okay. Palo Alto Digital Library Project. Right. So what are we doing? Books are stored in the host corresponding to the first digit of their call number, while the book's ID is 200 plus the last two digits of the call. Okay, so we're going to need Swizz. For example, book 512 will be stored in the host 500 to 590. Okay, so it's on the. Okay. So it's based on the Dewey Decimal System. Got it. As file 212. Duplicate each of the books requested by Ember 2 and bring them back to your host. The call numbers for the books Ember 2 wants are available in file 300. Note that Ember 2 will never request more than one book from the same host. Right. Okay, so she's not going to want that book and that book. She's only ever going to want one of the books. Or they are never going to want one of the books. So, okay, well that, all right, okay. I think I got a pretty clear idea of what we need to do here. So, we're going to need 2 exes, straight up. Because this is kind of like the tape deck puzzle that we did a few levels ago, where we need like, you know, it's pin the tail on the donkey. Like we need like one of the exes to be like, is this it? Is this it? Is this it? The other one like looking down at the map being like, no. But it needs to do. Oh, but hold on. What is the? Okay, hang on a minute. I just want to do a test first. Link 800, and then link 800, and that puts us in our first one. And then I want the host name, which is what was it? It's host. I think it's just host and then register, and then tell it where to copy that to. Yeah. So then we're going to go host and write that to X, and I just want to see what that does. So it gives us 100 to 199. Ooh, see, that's tricky because no, it's not. Can we do a Swizz on that? Can we do a Swizz on that keyword? Because if we can do a Swizz on that, we only need that. We only need the first number here, like 1, because that's all we're looking at here. So yeah, theoretically we should be okay. So okay, host X. We're not going to put this in a loop for now. Let's just write this out straight and see if we can like Swizz it. So we're going to copy X to M, and then you're going to copy M to your X file. Excuse me. And then we're going to swizz the X register, and we want the we only want the 100, but I don't know if that's going to do it. And copy that. I'm going to copy that into the T register just to like literally see what happens, and I just want to see what happens. So it sends that over, and then it swizzes it, and what do we get? Oh, numeric value required. Right, so it's not accepting that as a numeric value. Right. Okay, so swizzing's out. Okay. So we need to figure out another way of... We need to figure out another way... Well... No, wait, no, no, we don't. No, we don't. No, I'm overcomplicating it. No, we don't need the host at all. We don't need the host at all because we just need the book. We just need the book number. It's still a comparison. It's like, is this the book? Is this the book? Is this the book? Yeah, and you just move your way on through until you find the right book. Yeah, okay. No, we don't need the host name at all. Yeah. I was kind of on the right track, but yeah, instead of a host name, you're going to Okay, so what we're going to do is you're going to grab file 300 because we want to make sure, and then you're going to copy what's in that to your X register. Because we want to keep pinging it without moving the read head too much, because we only want it to move when we do it once, because that gives us our next word. Remember when we were replacing email files? It's that. We're doing the word search thing, but we're just doing file names. How do we do this actually? Because it'll blow itself up if it can't find the file. Maybe we need to replicate. Maybe we need to replicate again and send the replicator thing through. And do a check. Yeah, but how do we get that to loop? Okay, this is a little bit trickier than I thought, but I'm pretty confident that I know the solution. We just need to figure out how to like write that solution down. Maybe we make a counter. Yeah, that'll work. So, okay, so we only need to link 800 once, because then we're going to do, yeah, so we're not going to do a copy X to M. Then we're going to mark, and we're going to do a file loop. Well, we're going to do a search. Let's do a search first. How do we copy books? We may need a third exa, but that's okay. That's okay. Well, let's get the search. Let's find the books. And once we've found the books, we can tackle the problem of copying the books. Let's break that problem. So our problem is threefold. So we need to it's twofold. We need to find, it's three actually. So we need to first figure out how to find the books. Then we need to figure out how to copy the books. And it really only is two problems. Yeah, we need to figure out how to find them and how to copy them. Yeah, so let's figure out how to find them first. Okay. So you're going to link over. And... Oh, but how do I get this to... I'm going to add 2x1 because we're going to use the X register as our counter, because that'll tell us like how far in. Oh, wait a minute. Yes, wait a minute. Okay, hang on. No, replicating is too complicated. What we're going to do is is what we are going to do. You're going to copy F to X, then you're going to copy that to the M register, and you're going to send that over to this EXA, who is going to copy that into its X register. And then it's going to swizz that, because that is a number. It is going to send a whole number, 512. We only want the 5, because that tells us, wait, hold on. Maybe because we're going to go 1, 2, 3, 4, 5, like that. So we're going to swizz from X that third value, and I'm going to store that in X, and that's our counter. Yes. And then we're going to do our search loop. So we still need a search loop, but our search loop is way less complicated, because now you're going to link 800, and then you're going to subtract 1 from X. It's sub I. And then you're going to test if X is equal to 0. And if it isn't, you're going to jump back into search. Cool. So that'll just move itself along until it reaches the right directory without having to do any file searches and crazy replications and all that sort of stuff. So that just does that. Once it's in the right directory, it then needs to get that file name back. So it goes, hey, can you tell me what that file name is again? So that's no problem, because we can then just copy X to M again, because remember, we've still got that name stored in here. We haven't read from here again, so we don't need this yet. We don't need this file again for a bit. So it's going to copy that over again, and then it goes, okay, so we're going to copy, actually I'm going to just put that on a separate line just to make it easier for me to see. And then we're going to copy M to X. That tells us our file name. Then we're going to grab that file, and then we need to get to our next problem, which is copying the file over. But let's test that this works. So I'm going to move over, and you're copying 512 over to your X register, and then you're going to send that over your M register, and you're going, yes, sweet, I've got it. And then I need that number there, that value 5, and we've got it. So now we're going to link 800, we're going to subtract 1, we're going to check if it's at 0, which it isn't. So we're going to jump back, and we're going to link 800 again. And we're just going to move all the way through, and hopefully we get into here. And we're at 0, so it's true, so we fall through. And then we say, hey, what's the name of the file? Yeah, it's this file, and then we grab that file. No, we didn't. Why not? We stored it as... Oh, the file ID is 200 plus the last 2 digits. We need to do a little bit more. Oh, hey, thanks, man. Thanks, Kronos. That's nice. So much nicer than mine. Thank you so much. It ain't perfect, though. It just broke. And I know exactly why, though, because we need to do some more swizzing. So what we're going to do is we're going to copy M to X. And then we need to do a swizz. But we want to, instead of extracting a number, we want to replace a number. How do we do that? How do we do that? Where is it? Where is swizz stuff? It's up here. Okay, so I want to replace a number. No, I don't want to do that. 1211 9899. Yeah, okay, so that's that. But I just want to replace a number. Oh my god, what if we don't? What if we just... No, what we're going to do is we're going to extract the last 2 numbers. Because we only need the last 2 numbers. We know it's going to be 2 whatever. So wait a minute. So 0, and then we want 2 1, like that. And we're going to write that into X. Oh, right, hang on. We need a registry. Yeah, so we're going to do that. Then we're going to add 200 to that. Add... in X 200, write that to X. Yes, that should work. Cool. And then grab X. Right. Okay. Because we don't need the 5. So we just need to get rid... Yeah, instead of replacing the number, we're just going to ditch it because we don't need it. So we just ditch that number and we add 200 to whatever it is. So basically 512, we swizz out 12, add 200 to that. So 12 becomes 212. which is the file number. And then bang, and then we've grabbed the file. So now we play pin the tail on the donkey. And around and around we go. And then we're in the right spot. We say, hey, what's that file number? We grab the last 2 digits, which is 12. We add 200 to them. And then we grab that file, and that's file 212. Yeah, baby! Oof! I love it when a plan comes together. Oh, I'm just full of old TV references tonight. Oof! Okay. I'm excited. Now we need to move on to problem 2, and that is how we copy the damn book. So, this should be kind of straightforward, because I'm guessing they want the entire thing. I'm guessing Ember wants the whole thing. Duplicate each of the books requested and bring them back to your host. Yeah, okay, so let's have Exa take care of that. Well, okay, we actually need to write some more code here because we need this to like happen in a loop for a bunch of books. Actually, yeah, wait a minute, yeah, because we only need to do it for those books, so hang on a minute. So we're going to call this a search loop as well. And you're going to just do this, and then you're going to do this, and then you're going to do this, and then you're going to test for the end of the file, which I hope doesn't read the file. If it does, we might have to do a seek instruction, but it's fine. And if false, jump back into search. And then otherwise, it'll fall through and just halt. Yeah, okay. So let's get to this point. Test EOF. All right. Blew itself up. Oh, because this is only happening once too. Yeah, because we still need to do some like stuff. Yeah. Well, let's mark this as read. Well, we'll mark it as copy. This is our copy instruction, and this is going to have its copy instruction. Yeah. Okay. So we need to flesh this out before we can flesh this out. There's a process to the workflow. Okay. So Exa is just going to, well, okay, no, it can't make straight off the bat. We need to have its make instruction happen on a Can we switch its mode over? Can we grab X and mode local? And then can they just communicate with each other then across the network, and they're only talking to each other? Maybe? Damn, man. We're gonna run into memory problems actually? Because okay, so that won't be there. So 1, 2, 3, 4, 5, and that'll be held by Exa, so that's 6. So wait, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Yeah, but is there any more than 5? 2, 4, 1, 2, 3, 4, 5. I think 5 is the most. Okay, so we shouldn't have any memory problems. We shouldn't run out of memory by doing this. But hopefully not. Hopefully we don't run out of memory problems. I don't have any memory problems. Otherwise, what we can do is like Exba, who's like doing the file search, can grab the file and just like sit out here and do that. And then at the end of the file, we'll just like wipe that, and we'll just wipe the file and like delete ourselves, and that can like honestly like free up an extra memory slot if we need it. But I'd rather not do that if I can avoid it, just because it's more instructions. Okay, so right off the bat, it needs to be in a loop. So we need to mark a well, let's call it a copy. Let's call it copy as well. Because then we know that these two are connected, just like search and search. So mark copy, and it's gonna copy what's in the M registry to the file, I guess. It'll need a kill command though, but I need to make sure that. Oh, hang on a minute. Does everyone have a ... Oh wait, but we can't test for that. Because we can't copy, I can't write in that as it's not a numerical value, so I can't test against it by typing it in. Like I can't do a test if X is like equal to like butts. Like I can't do that. Like it won't let me do that. I wish it could though. If I could test against keywords like that, oh, that'd be so good. But it's like, no, I can only do it for numbers. And I'm like, fine. So copy M to F. No, copy M to X. Copy M to X because we need to do a test. Copy M to X, test if X is equal to minus 9999. If true, it's going to jump to an end, which will be down here. And that'll just be like a halt. No, not a halt instruction. It'll be something else. Whatever. We'll have to do like a next book. Actually, yeah, it'll jump to next book. So it still needs an end instruction, I think, but then we'll have a mark next book. And that'll be like drop that file, make a new file, ready to rock and roll once more. Yeah. But we need to know if we're at the last book. We'll figure that out later. We will figure that out later. Let's just make sure that like we can write a book, drop it, make a new book. If we can do that, then we can figure out how to make it stop. It's just breaking a big problem. It's just breaking our problems down into smaller and smaller problems. We broke it down into two. Now we're breaking that one down into its little tiny component pieces and solving them piece by piece, which is the way to go. So next book. So yeah, so we're testing that. But if it's not that, if it's like literally a word, you're going to copy that word into the file, and then I guess just jump back into copy really, and just like receive the next word is kind of the way to do it. Yeah. Yeah, that's the way to do that. Okay. So next book, what it's going to do, when it receives that minus 9999 instruction, it's going to drop the book it's holding, and then it's going to, I suppose, wait for another instruction. Yeah, so copy M to X. Oh boy, no, that's not going to work. Because I mean it could, but it would interfere with our copy instruction. So maybe copy is not the way to go there. We still need to drop. We need to drop the book that we're holding because we want to effectively save that book. And then how do we do this? Once we've dropped the book, because we need a way to test if there are any more books coming. And I suppose... Well, we could just do it... No. Oh, by the way, this needs to be on local. Oh, no, it doesn't. Oh, dear. Oh, right, no, it will, because we're gonna switch to local when we do all of this. Yeah. Well, let's write this in. Let's. I don't know how to like do the next book stuff, but we're gonna figure out next book later. Let's get this ex's copy. Once we've got the right file, it's going to copy F into its X register. No, you can just copy it straight into its M register. Yeah, and then test for the end of file, and if false, jump back into copy. Like, I think that one can be that simple. And then when it reaches the end of the file, you're going to copy minus 9999 to the M register and send over and say, hey, we're ready for the next book. Then it needs to mode because we need to go back to talking to Exba, who's on global. So this all needs to kind of happen separate. And then we need to... this all needs to happen into its own loop. Oh, no. Yes, it does. No, this needs to be in its own loop as well. So mark as start search. Oops, mark as start. Because what we'll need to do is it gonna do it in order? No, 5, 12, 5, 8, 2, 3, 1. Yeah, that's what I figured. So we need to like basically like go all the way back to like the start, and I think the best way to do that is to just like rewind, but we don't know how many times we would need to like link -1 to do that. Because it's going to do that, it's going to talk, it's going to send its stuff over, and then, well, it needs to drop the book, it needs to drop the file it's holding as well. I totally forgot about that. Then it needs to send its next book code. But how do we get it to work out? Because it knows it once it's in here. So, okay, so we know we're at 512, and then we need to get to 896, but moving forward is kind of not a problem. It's moving backward that's the problem. Maybe we do replicate. Like, we could put this into a replication instruction, and then like once it drops, it sends off its 999M, and then it can like, yeah, but then I got to get it to communicate with another egg. Yeah, no, that's, yeah, no, because that makes 4 exes in the thing, and that makes communications really bad. So no, we're not going to do that. We just need to figure out how to make this thing move backwards and forwards, and it's already got it listed here. Like, you know, to move forward is 800, to move backward is -1. Like, it's already telling you that's kind of like part of the solution is you got to figure out how to move forwards and backwards in a thing. But maybe I could do some simple mathematics, and like I could do a like we know the maximum value is 9, and if we can see if our and if we like the problem is I need to figure out, like, I need to get our current position back. So if I can get our current position back, is it greater than or is it less than? And if it's greater than, then we move up towards it. If it's less than, we move down towards it, so to speak. So like if we're at 5 and our next spot is 8, 8 is greater than 5, so we're going to link 800. But if our starting position is 5 and our next position is 2, 5 is greater than 2, so we're going to move backward. It's kind of what I need to do a test for. And then it's simple enough to like subtract, if it is at 5 and we want to get to 2, it'll go 1, 2, 3. So it'll like 5, 5 minus 2 is 3. And so then we move 3 times. 1, 2, 3. Yeah. So that'll give us our, so we could, so what we need is we need to actually get our original position back, which, so that's doing that. Test for the end of file. If false, jump to search. Maybe what we do is actually, because it needs actually another copy X to M, because that'll give us our position again. Wait, yeah, because so hang on a minute. Let's I just want to see how this works right now. So copying our file, yep. So our word into there. We're gonna send that over to Exa, and Exa's like, sweet, I want this. I want to do this. All right. Oh yeah, and it did its swizzing, so it can go and play that. So now it's copying it again. Oh, that's right, and we're copying it a third time. That's right. because now we need to do our file thing and grab and then drop it and then do a mode. Right. And then it's going to send... Wait, why is it not... That should actually... we wrote that out. Why is that not... Oh, because they're not in the same... Ah, damn. Okay, that's a problem. I thought them being local would just mean they would exclusively talk to each other. No, it means that they can only talk within within a host. Right. Okay. So... that's a problem. That's a problem. So switching it to local doesn't help. And having this start at local doesn't help at all. See, now we've got 3 things trying to talk all over the one channel, and that's a problem. So maybe we don't. Maybe Exa goes into the loop with it. And then writes the book right there. And then once it's written the book, it can take it back and drop it off. I don't like that idea, though. I really don't like that idea. It's not... Yeah. It would mean that they could communicate freely, and it would free up some space on this. Oh, what's this? What do you want? Oh my god. Okay. Alright. Yeah. But also, like, how do we get it to move over? Like, how do we do that? Because it can't send... I mean, we could increase the number of times this just sends the same message. That's kind of not a problem. Well, we just have to change... We'll copy M to X and Swizz. We could have them both do that, I guess, and then have that be still local. No, because it needs to be global. No. It can be local because it's talking just in here, I think, which will be fine. Yeah. See, now it's getting too complicated. I still need to figure out how to get it to write a book. Maybe we do that as a replication step, actually. And have it write its book and then, kind of run all the way home. So so instead of having a whole separate exa, right? We just have it get there, grab the book, replicate itself, grab the book, and then just send it over to its little clone, and then its clone goes, great, I've got this book, and then will run itself all the way back. Yes. And it's simple, and that's simple enough because we can just grab, again, we need our location data anyway, and we can send that, so we can have our first exa grab its location data for the 3rd time, which it still needs to move backwards and forwards, but it can communicate that location data back to the clone once everything's done, and then it can do a little swizz to get its counter, and then we can add to that counter, because if we had 5, right, if we're here and we said 5 again, that's 1, 2, 3, 4, 5, and we actually want to go 6 because we want to come back into the host and drop the book. So we just go add, like, swizz out that 100 value, add 1 to it, and then count yourself back -1, this little piggy ran all the way home, halt, drops the book. That, actually, I don't mind that idea. I'm going to keep this exa here for now, just because I want to copy that code. But once we've found the book, let's see. So once we've found the book, we still need to do this. So we need to find the right file. Yep, so once we've found the right file, does replicating... If I replicate the exa, will it replicate whatever it's holding? I don't know. But let's find out. let's say, I mean, let's find out. I don't think it does. That would be insane. Like, why would it do that? Replicate, and then we're gonna send it over to another. Well, no, because we want that to all happen kind of at the same time. We're gonna put the replication instructions in here. So mark as clone copy. Clone copy. And then set itself to local. Or do we want to set itself to local beforehand? Actually, no, let's set itself to local before, so that the clone is also in local. Yes. Okay, and then we get our clone. So I'm just going to put nothing in it for now, because I just want to see what it does. So it's now going to replicate itself. No, so what it's replicating isn't holding anything. Great. Okay, excellent. That is super, super, super helpful. Okay, cool. So the replicated thing is going to make a file because it wants a file. Shut up, phone. Let's see. So it's going to make a file, yes, and now it needs to start to receive instructions. Yes, but Exa needs to send it the instructions. So it's going to, it's going to go, it's just going to do this, isn't it? Yeah, it's going to copy that into there, and it's just going to keep doing that. Yeah, so we're going to test, so we're going to copy M to X, test if it's minus 9999. Oh, whoops, right, I forgot to put in my register. So test if X is minus 9999. Why is it having a problem with that? Oh, wait, right, because it needs an operand. Okay, is equal to 9999. And if it's true, it'll have to go to an end. Well, it'll need to go to a home step, but we're gonna deal with that in a minute. So if true, jump to home. Otherwise, you're gonna copy what's in your X register into your file, and you're gonna jump back into clone copy. Okay, and so that should just copy. That should do pretty much this. Yeah. Okay, so we have copied this now successfully. Okay, yes. And then we don't need a next book step because home, we need to hold the file. Still need to hold the file, but we now need to get another copy of M in its X register because we need to get our file. We need to get our location again. But before we do that, remember that Exa will be on the global mode, and it needs to copy M to its X register, and then mode again to local. So now it's got its position again, and then it needs to copy that to M to send it back. This is this is not clean. We're always gonna get a little bit dirty with our code. This is not clean, but like it's gonna, by God, it's gonna work. Okay, so we're gonna copy that over so that our clone knows where it is in its home step, and then it needs to mode again back to global because it now needs to learn where it's going next. Yes. Yeah, but let's get the home step. I'm not quite sure how to work that out yet, but let's get the home step sorted. So now for home, it's going to swizz the X register, and we're going to pull out that third value, and we're going to write that into X. Actually, oh yeah, no, because it's going to jump. Yeah, so yeah. So we're going to jump to here. We're going to do this, and then. I'm gonna call this phone home because we're just like, what's our address? And that's what we need. So phone home, ET phone home. I'm just gonna keep up with the theme of today, which is like movie references, film and TV references. So we got phone home, and then we're gonna mark another home step because now we know what. Well, actually, we're gonna swizz, and then we need to add one to that because that's just going to get us to here, and we want to get to here. So now we're going to jump. No, we're not going to jump. we are going to test if x is equal to 0. And if true, it will jump to an end step, which will be the halt instruction. Otherwise, it's going to link -1. Then it's going to subtract. Subtract from x 1, write it back to x, and then it's just going to jump back into home. So it'll just keep doing that until it comes, and it'll go, wee all the way home, run all the way home, and then it'll blow itself up. Cool. And that more or less cleans up. That's like, cleans up that clone quite nicely. And then we don't need any of this. So now this exa is useless. We just need 2. Okay. Cool. Alrighty. But now we need to figure out how to do we? Because now we need to figure out. Okay, so because we have to do some maths on where we're going. So, oh boy, how do we do that? Because the problem is, I need to store 2 numbers, and I want to do a test on 2 numbers. So that's a problem. Well, let's make sure this all works first. Before we even worry about getting to the next book. Let's see if we can write one damn book. So we're gonna jump over, and it's getting its address. It goes, okay, where am I going? I'm going this way. Okay, so it just then moves its way through. It goes, I'm going here, and then I need you to tell me where I am again, because I don't know where I am. Oh, I'm here. Okay, well, that's the file I need. Cool. I'm going to switch to local. I'm going to create a clone, and then I'm going to tell that clone to do the things. And it's going, cool. Yeah, no worries, Cronus. You go to sleep, my dude. That's all cool. Have a good night, man. Alright, so we're going to do this, and then it's going to move over to here. Alright, and now it's just sending... Wait. Why is it getting stuck? What's it getting stuck on? Yeah, I'll see you around, Kronos. I'm going to be streaming this actually, I won't be streaming this for the next couple of days, actually. I'll be back on Thursday. I'll be back on Thursday in my time here in Australia. I don't know what that is locally for you. But basically the same time I came on today on Thursday for me, which might be a Wednesday for you if you're in the States, or depending on where you are on the globe. But I won't be back on for at least a couple of days. This is basically my Friday, so to speak. So yeah. All right, but I'll see you then, hopefully. Okay. So why am I getting stuck? What am I getting stuck on? Oh, wait a minute. Why did it halt? Hold on. Let's jump into there. Oh, okay. It's trying to make a file multiple times. That's the problem. Okay. Okay. So what we need to do is actually put clone copy. We need to put this in a separate thing, and we're going to call this write file or write book. We'll call it write book. Right. That should solve that problem. Okay. So then we replicate. So we get to here, then we replicate, and then we're here. And it makes a file, and then it wants to copy. Oh, wait a minute, but we need to change where we're jumping. So so we don't want to jump in a clone copy. We want to jump into writebook. Okay, that should solve that problem. Let's go back to here. Okay, and then we copy M to the X file, test if it's no, and if it isn't, so then we're going to write that, and we're going to jump back in here, and we're going to keep doing that, and we should... Ooh. Wait. Did it? Yes. No, that is correct. That is literally... Yeah. Okay, so then it's writing its book, which is quite nice. Okay, so now What's the end of the book? What book are we on? 212. Where's 212? Oh, it should be under Exa, shouldn't it? Yeah. Okay, so importantly, and then we get to here, and then we get to here. Okay. Then we test for the end of the file. Drop it. Send a -9999. Which it is now checking for. It jumps to phone home. It's now going to wait for another instruction, which it received. Then swizzes that, adds one to it, and then it starts to make its way home. Cool. And then it should just halt. Yes. Okay. So we can actually, in fact, save one book. But while we were doing that, there was some other weird stuff going on for some reason. For some reason, it was constantly sending... yeah, so... we do that. We go to global. Or go back to global, grab our position, go back to local, send that position, go back to global. And we need to... Right, so this is... Okay, so everything else we've done works. Okay. Okay. So... just a file. So the first time it's sending it for the address, second time it sends it for the file, third time it's sending it for its third address. Then we jump back, we copy the next number, and then the first time we send it for the next book is just saying, this is the next address. Yeah. Okay. Yeah. So okay. So yeah. So that loop should still work. We just need to make it work within this. Okay. So the next one is 896. So maybe we can we. Ooh. What if we added the two numbers together? So then, like if we swizzed out 5 and 8, that's greater than 10. But if we subtract, oh, but that still doesn't tell us to go forward or backward. Yeah, no, it doesn't. But would it give us the correct address? So if we're at 5, okay, so 5 plus 2 is 7. No, because 5 plus 2 is 7 minus 9 is a negative number. That's not going to work. Unless it does. Unless being a negative number, if it's below 0, we have to go like -1 maybe. No, I don't like that. I'd rather do a greater than or less than. But I suppose I could do it temporarily. Well, no, because I need that new number. But I need the new number first, don't I? So what if I copied X into the T register, copy M into the X register, then we do a test, which is going to get rid of what's in the T register, which is the old address anyway. But we need to see if it's greater than or less than, and I don't know how to do that. Because I can't test it twice. We're only going to get one test before the T register wipes to give us a true or false. we may as well write out test, because we're going to test something. We're going to test if X and T... maybe if it's less than... hang on. Okay, if it's greater, then we need to move forward. Maybe. Oh, it's probably dirt simple. It's just I suck at maths, which is what makes these games like way harder for me. But it also means like that it's it's twice the challenge. Let's see. X is greater than T. I think I can do it like that. Pretty sure that's how that test works. Test instructions. Just in the file. Yeah, no. Don't want any of that. Don't want any of that. Okay, so you can just use greater than, less than, and it tests. Okay. Oh, number and keyword are always false. Okay, never mind. Ugh, I was thinking maybe we could use the host and like do a test, but it's the host name is treated as a keyword, not as a. It's treated as a string, as a word, not as an integer number, even though it is written as a number. And I just read the manual. Whenever you test a number against a keyword, it always comes out false. So okay, so we can't. I was thinking we could probably skip this whole thing and just do a straight. But I mean, we still need the value anyway, so we may as well test it. Is it greater than T? So wait, what's in T? So T is going to be what was in X. So that'll be 512. And then this will be 896 just for now. And if X is greater than T, if it's true, it needs to go somewhere. So if 512 is greater than, yeah, so, okay, hang on. Well, let's... Yeah, okay, yeah, because that'll mean it will go backwards. And we actually want to test if we need to go forwards, so less than. Just for this next step, because if otherwise it'll jump, we're going to have to make a jump either or, aren't we? So if it's true, you're going to have to jump to a forward instruction, which will be search, won't it? Wait. Yes. So it'll jump to search. If it's going forward, it can just jump to a search. But this now needs to happen in a separate thing. Mark, because we need this. So this will be, what's this? This will be mark find file. Call that. Otherwise, we need to go backwards. And we'll put backwards down here. Mark move back. Because it can just fall through. But how far back does it need to move? Crap. If it's less than. But now we don't know. We don't know by how much it's less than. No, that's not going to work. That is not going to work. This still needed to be in its own thing, I think. No matter what what we do here, we still need to be able to jump into this or jump into this or this as separate things, I think. Yeah. Okay, but this needs to know when to stop, though, because this won't stop. It'll just freeze at an instruction. That's actually a problem I can solve. So let's solve that, because otherwise this is just going to halt at the end of a file. So once it's at the end of its file, though, it needs to send a kill instruction. And then end. That's fine. So where is it receiving that instruction from? It's receiving it here, isn't it? Yeah. So actually, let's copy. Ooh, this is not clean. This isn't going to be clean, but that's okay. If I need to add more like copy steps, I'll do it. I don't care. It's fine. So instead of copying it, so we're going to do. Actually, wait a minute, because so this is happening in local. Then it goes to global, then back to local, back to global. And you're going to copy, so get rid of that instruction. And you're actually going to test if x is equal to minus 9999. And if true, jump to the end. Okay, so that solves if we've done all of our books. Okay, otherwise, you'll need the old step again, because we need to check if one's greater than the other, I guess, is what we need to do. So I'll need another copy. So which it's not going to send. It'll just send the next thing. This number's now gone, which is a problem. So how does it know where to go next? I suppose does 212 have that information in it? Yes, it does. So maybe we don't drop the file. Maybe what we do, before we drop the file, just don't drop it. We're going to hold on to it, because that has the information in it. Right, okay. And we can compare it against that. Yeah, that gives us our two numbers in our truth register. Yes, okay. So if that's true, otherwise, what you're going to do is you're going to, because we need to go all the way back to the beginning, which I think is minus 9999, if I'm not mistaken. We need to go all the way back to the beginning of that book file, which will be that. But you haven't received. Have you received? You have. Okay. So you're going to seek, and then we're going to test if we're going to do the test instruction on F, because they're both numbers. Yes. Okay. I think we're getting closer here. So we're going to test if X is greater than F, and because I think every book has its Dewey Decimal number as its first. Yes, it does. Okay, cool. Which allows us to then, okay. So that's the value. So the value is already there. So let's take advantage of the fact that the value is there. Okay. Right. Okay. So we need to do some swizzing on it. Yes, we will. So, so actually, no, we can't jump to search just yet. We need to jump to move. We need to jump to a move forward instruction. So we still need one of them. So mark move forward. So we have a forward and a back. So if true, jump to move forward. Otherwise, it won't be true, and we'll jump to move back. Yeah, I think that's the best way to do that. Okay, but that's if it's less than. So if x is less than the value of f... Ugh, I hate less thans and greater thans because it's such a pain in the butt to keep track of my head. Right. Okay, but we can now do some maths on it, like straight up, like we totally can, because we're still holding the file. So, we are too actually still holding the file. Ooh, that's a problem. Because we can't take the file with us. We need to like drop it, but we still need to do more maths on that file actually. So that's fine. We can just leave it and then set ourselves. Well, actually, yeah, because then we've set ourselves up for this to more or less happen, haven't we? Yeah. So if it is greater, if it is greater than, so if x is greater than f. Oh god. Okay, hang on. I need to write numbers down, because otherwise I'm just going to confuse the crap out of myself. So I'm just going to make a note in my note-taking app. Where the heck is it? Oh god, I never use the damn note-taking app. Screw it. I'll just put it in the calculator. Okay, so the two numbers that we're going to be testing for now are 512 and 896. So 512 and 896. Okay, there are two numbers. Right. Oh, that doesn't actually help. No, putting it in the calculator makes it worse. So what I need to do is I need to write in. Is it under here? Where the heck is my note app? Or is it, where did I put it? I just put it somewhere. Oh, I've done gone and lost my notes app. I thought I had it. Hang on. No, it's not there. Where on earth is it? No, it won't be there. It won't be there. They might have just gotten rid of it. You know what I might have done? I might have deleted it. I might have gone, I don't actually need this. I never use this, so ditch it. All right, that's fine. We'll have to do it this way then, which is fine. I don't care. Let's go into general notes. Okay. And I'll just call this Exapunks scratch paper. Scratch paper. Okay, so what is going to end up in our X registry? So it'll be that second. So okay, so X at this time is going to equal 812, and F is going to equal. Is it 812? No, 896. 896, and F is going to equal 512. Yeah. Okay, that's better. Okay, now that I can see them like in front of me, that's a really nice. I don't know where to put my phone though down. Where I can see it, like there. Can I see it there? Yeah, I can see it there. That's fine. Alrighty. If you hear something go clunk, you'll know that my janky solution to holding my phone up so I can see it didn't work. Alright. So, is X less than F? X is not less than F. So it's false, so it's going to move back. So then we need to seek -1 because we want to go back to that number. because every time we read the file, it's going to move forward. So we want to go back to that number. And then we want to do more maths. So if I subtract... Yeah. If I can do a subtract... Wait. But I don't want to do... Ooh, I don't want to do a subtraction. Well, actually, yes I do. Hang on a minute. Copy, because we don't need to do a test anymore. So now we can just copy that into our T register, because then we can then we're going to do some swizzing. So we're going to swizz X first. I'm going to take the hundreds value. I'm going to store that. We're then going to swizz the T value. I'm going to do the same thing and store that back there. And then we're going to subtract the two values, which will give us... No, we don't. No, because we want to move... Yeah, no, because we want to move backwards. So if we're at 5, we want to go to 2. Well, yeah, so if we were at 5, we wanted to go... No. Wait. Is X greater than F? X isn't greater than F. So we wanted to move forward. It's X less than F. X isn't less than F. Oh, I think I've got these backwards. I actually do want to move forward. If X isn't less than F, yeah, I've got these backwards, so that needs to be moved back, and this needs to be moved forward. And then everything I've written in here so far needs to go into here. So now we're going to subtract. We're going to subtract from X the value of T and write that to X. Yes. Yes, that is what we're going to do. And then then it can jump to search. Or do we need to... Yeah, no, then it can jump to search, because then... So then we take the 8 and the 5, so we subtract 5 from 8, and that gives us 3, and that gives us 6, 7, 8. Yeah, and so then we jump into search. And that'll work. That will... Yeah, we can just jump back into search, and it can just go forward. But let's see if that worked. I might have this all confused, but let's get to this step. Why not? Let's go to this step. Okay. So it's gonna, wait, why is F212? What the heck? Oh, wait. Did it, is it testing that value, or is it testing... Oh, hang on a minute. I might have stuffed something up. Hold on. Seek minus 9999. Back to here. 896. Jump to move forward. Okay, no, it did. Okay, it wasn't testing this. Or it might have. I don't know. Maybe it didn't work. I don't know. Okay, so copy that into the T register. Swizz those two numbers, subtract them, so that gives us our 3. Jump to search, link, cannot move. Oh, yes. Okay, yeah. I forgot to add the drop step. There. Okay, all right. Let's try this again. Drop the file. Up along Cassidy. Get its next instruction. And write your next book. Okay, so that worked. Okay. Alright. So we can move forwards now, but I still don't know if we can move backwards. Well, we can't move backwards because we've got no code. We've got 0 code for moving backwards. Okay. So I don't know how to move. I don't actually know how to move backwards. So if those are flipped, let's say they're flipped. No, No. Let's do the next set. Let's actually do the next set. So the next one, F will be 896, and X will be, wait, no, not 806, 96. Well, no, it doesn't matter. And then X will be 206. Okay, so, all right. So is X less than F? It is. So then we need to do some more maths. I still think, and I think the best way is still to seek -1, because we still need to swizz, don't we? Yeah. Oh yeah, we do need to swizz, and then I guess we do need to loop, but we just need to loop backwards. So we could put, yeah, actually, here's what we're gonna do. We're gonna jump to find file, and we're gonna put it in here. Oop, stop that. We're gonna put our mark, and we're gonna call this search back. Okay, and then it'll actually, it can just kind of do basically this, but we don't need to jump to find file, and it can search. It'll do a jump back to here, and instead of doing this, it'll do a link -1, and then do the exact same thing. Yes, that works. Okay. So for move back, we need to seek -1 just to make sure, because we're still holding the file. And then we want to do, I think, some. Well, we definitely want to do a swizz on the X register, because we still need that value. And then we need to swizz. We need to. Wait, what did I do? I copied. Oh, that's right. Seek -1. Copy F2. Actually, you know what? Instead of having the drop instruction here, let's put the drop instruction up here, because this is where it makes the most sense. Because once we've copied that file, we literally don't need it anymore. So like, let's just not worry about it. Yeah. So copy F to T, and then drop the file because we don't need it anymore. So you're gonna swizz that, and then we're gonna swizz the T instruction. We're going to do the same thing, and we're going to store that back into T. And then what we actually want to do is we want to subtract. We still want to subtract the higher number from the lower number. Yes, because that, yes. So if we subtract 2 from 8, that gives us 7. So 8, 7, 6. That gives us 6. So, and we want to go to 2. So 6. So wait, so it's 6, 5, 4, 3. Wait, no. So it's 6, 5, 4, 3, 2, 1, 0. Yeah. It's just subtracting the bigger number from the smaller number. So then we want to subtract, and the bigger number in this case will be what's in the T register. Yeah, which will be F. So we're going to subtract T. No, we're going to subtract X from T and store that back in X. Yeah. And then we're going to jump to search back. Okay. All right. Okay. So now we can move forwards and backwards through our library, and we've got an end, and that should work. That should work. Fingers crossed. Okay. I think I've done it. I think I've solved it. So basically, okay, I'm gonna run. Let's run through the order. Let's just run through the code. So Exa is going to jump into here, and then it's going to copy what Exba is telling it, and Exba is going to send it this number 512 first. It's going to send that over, and then it's going to subtract the first number from it, which is the number 5 in this case, and store it back in its X registry. Then it's going to link over from here to here. So we're starting at 1, and then we're going to subtract 1. So we're going to go to 4, and we're going to say, hey, are we at 0? No, we're not. So we're going to jump back. And we're going to move all the way along, subtracting from our counter until we get to where we want to be. Once we're where we want to be, we're going to jump into find file. We're which is right here. And then we're going to ask Exba again, hey, give me that number one more time. And Exba has been like, I got you, fam. I'm going to send you that number again. And it goes, okie dokie. So the number I wanted was 512. Okay, so then we're going to swizz the last two numbers from it because we don't need the 5 anymore. Now we need those other two numbers. And we're going to add 200 to those because every file is 20 whatever or 2 whatever. So in this case, 512 becomes 212 because then we're going to add 200 to that, and then we're going to grab that resulting number, the file with that resulting number. In this case, 212. So we grab that, and that's the correct number because 512 is the address. So number 5, file 12, and every file inside is called 12. So that'll be file 212. Then we're going to write our book. Well, once we've done that, we've found our thing. Then we're going to go from global talk to local talk, and we're going to make a clone. And our clone starts here, and a clone's going to make a file, and it's a scribe. So it's just going to copy whatever's in its M registry into its X registry. It's going to say, is that its kill code? It's not a kill code. So it's just going to copy then whatever's in its X registry. It's going to write that file down and then go back. And it's just going to keep doing this until it gets its kill code. Before it gets its kill code, though, here's our copy. So the original exa, which has picked up its file, continues on, and it just copies whatever's in the file into the M register, and it tests if we've reached the end of the file. If we haven't, we just keep doing this until we reach the end of the file. Once we reach the end of the file, then we send the kill code. And then this is where things get a little bit complicated. This is where stuff kind of gets complicated. So basically, we're then going to send the kill code over local. We're going to go back to global, and we're going to ask this exa for our next address. For the same address again. And say, where are we? Because we need to know where we are. And we go, okay, yep, we're here. And then it goes back into local, and then it sends that back to its clone, because its clone now needs that address, which it then removes the first number from, and then adds 1 to it, because remember, if it adds 1 to it, and then it works its way back home. So it just goes backwards through the network. Now, the reason why we add 1 to the number is because if it's here, 5 minus 5 just takes it to here. And we need it to go that one extra step to go into its directory. So instead of adding an extra link -1 at the end, we just add 1 to whatever that number is. And that gives us exactly the number we need to get back to here. And then once it's here, it just blows itself up and drops whatever file it's holding, which is the book that it just wrote. And then going back up to the original guy, the original guy is here. So he's done all of this to here. Right. So it's done all of this, and then it goes into global again, and it says, okay, I need the next place I'm going, and it tests if that's a kill code, and if it is a kill code, it kills itself. But otherwise, if it isn't a kill code, it's going to, because it's still holding the book in its hand, it's going to go all the way back to the start of that book, and it's going to test the first word in the start of the book is the address of the book, which is 512, which is exactly the number we need to know exactly where we are, and we're going to test if that number is greater than the number that we were sent for where we're going next. And that then determines whether we move backwards or forwards. And these basically work the same way. So if we're going forwards, we seek -1 in the book, because again, once we read the file, we move the header along, and we want that number back again because we need that number. We're going to copy that copy that number into the T registry, because we've already done the test. We've used our 2 numbers in our test, and we've already done our test, so we don't need to do any more tests for now. So then we drop the book, because now the book has served its purpose. It can't leave this section, so we can't take it with us. So we just leave it. Then we extract the 100 from our X value, because now we don't need it to be. Whoops! I just hit my Windows key. Because now we don't need the whole number anymore, and so we can just extract. We only need the individual number, and we do that to the T register as well, which has. So X has where we're going, T has where we are, and we only need the first number from both of those. and then we subtract where we're going from where we are, and we write that back into X, and that tells us how many positions we need to jump forward. And in move back, that whole process happens again, but in reverse. So we take where we are, and we subtract, we take where we're going and subtract it from where we are, and that gives us how many positions backwards we need to go. And that jumps from search. So search, which happened before, is just moving forward as normal. And then if we're moving backward, we've got a separate one called search back. And search back works the same way as search forward, but instead of linking forward, it links backward and then just runs the whole thing backwards through this loop. Okay. That is complicated AF. And look at our size, 85 out of 75. Like, there's got to be a less complicated way of doing this. There definitely is. There is definitely a less complicated way of doing this, but this is like the way I can see it. And then by the way, so once it's, I haven't explained the whole thing. Sorry. So it does that, moves forward, moves backward, and then it just constantly does that until Exba gets to the end of its file. And if it's at the end of the file, it then sends the kill code and then blows itself up, which I probably don't need. I can probably get rid of that instruction. Once it runs out of instructions, it can just blow itself up. It literally doesn't matter. I can save an instruction, but whatever. Like, oh no, I'm going to be 9 over instead of 10 over. It makes no difference. So it sends the kill code, which it's checking for back here at the end of after it's finished writing a book. And if it's at the end, if it is the kill code, it jumps all the way to the end and it blows itself up, which automatically drops the file that it's already got, so we don't need an extra instruction there. Right. Okay. Let's see if that worked. So there's it copying its book. Okay. And then it's moved forward and sent a book over. It's doing it again with another book. Good. It was able to... Oh. Nope. Something went wrong. Something went wrong. Oh dear. Okay, hang on. So it got to the first book okay. And then it got to the second book. And was that okay or was that a problem? No, the second book was a problem. Okay. Okay, let's go to this first book. And then we'll just... Okay, so here's our second book. 896. Okay. It's probably... So what it seems like is that our move backwards instruction isn't actually working. So... Yeah, so we'll just let it run through this to move its way through the book, because this bit seemed to be working totally fine. The team's owner had already blah. So then it sends its kill code, or sends its go home code. Then it's copying its address again, and then going into local, sending that over, saying here's where you are, and that's where you need to go. And then it sends, okay, where am I going next? And it's not a kill code, so then it seeks all the way to the beginning of its file. Okay, we're testing if X is less than F, which it is. So it jumps into move back, seeks -1, copies that into its T register, and then drops the file because we don't need it anymore. We need that, and we need that. Ah, okay, yep, all right. So this should be, yeah. Like I said, this needs to happen in the reverse order. So it needs to be TXX, not TXTX, which I had it as XTX here too. So no, because we need the bigger number to be subtracted from the smaller number. Sorry, no, we need the smaller number to, no, bigger number to be subtracted from the smaller number. Yes. Okay, that should now work. Let's run that. Okay. So there it is. It's moving through its second book. It moves backwards, gets to its next spot quite nicely. Moves forward. Okay, all right. I think that was it. I think that was the only bug. I think that was the last bug. All right. Test 1 complete. All right. I think that's done it. Yeah, that's done it. All right. Dirty. Is it the cleanest? No, but it works. We're writing all the books. Yo, that totally works. All right. 66, 69, 70. Yeah. All right. So that was it. Like that was the last bug that we needed to solve. And so we don't get a leaderboard because we're 9 instructions over. Whatever. I want to record that solution GIF though because that's looking good. Look at that. Look how good that looks. Copying the book and then moving over to the next step. Oh wow, how long is this GIF? Oh my god. Yeah, because then it does that. Yeah, well actually, you know what? That's pretty cool. I like how long that book is. That's how long this GIF is going to be. That's actually really cool. Yeah, because it needs to do it for every book. Yo, look at this, and it's all filling up with books as it takes all of its books back. Aw, that looks so sweet. Yeah. Man, this is a long GIF. Usually these GIFs are like, but this is like a properly long thing. How many books do we need for this one? I think it's 5. I think it's only, yeah, there we go. And it saves the GIF. Because I think I might post that to Twitter or something. Because that's cool. All right, processing. Yes, this is what I wanted. Glad it's helping? I didn't actually look at what books we copied over. I love ingesting a good corpus. Not that that's all I'm doing. I read the same way any normal human reads. By analyzing patterns of word recurrence and deriving correlations between concepts implicit in statistically significant word. Whoa, that's a ooh man, you got a lot of $50 words going on in there. Okay, hang on, I need to reread this. By analyzing patterns of word recurrence and deriving correlations between concepts implicit in statistically significant word clusters. Now I'm gonna need that translated into English, homie. Like that's some like, who, yeah, that's some PhD talk right there, and I'm just a wee bachelor. Yep, that's beyond me. All right. Oh, we got one last bit of chat. I'm hungry. What are some good snacks? I hear X10 loves Peanut Blast. Haha, yeah. Still can't believe they F that up. I would try one, but they don't have Last Stop out where I am. Whoa, you must be way in the boonies. Something like that. Oh. I wonder if Selenium Wolf is Ember. Maybe Ember's entered the chat. Ooh. But that's a thing for another time. So what's the one to grow on? What's the next one? Create a hit single by inserting it into the playlist of multiple radio stations. All right, well that'll be what we'll do next time, but that's not what we're going to do today. So thank you so much for joining me today. Oh my god, I can't believe that we finished that puzzle like right on the dot at 4:30. That's insane. Okay, well, if you know, thank you for joining me today. For watching me like basically like run my brain, like redline it right at the limit, because that's like, oh my god, that was me pushing myself hard trying to solve that one. Oh boy. Although not as bad as like cracking the redshift. That was like once we figured out the solution to the redshift, that, which is what I suspected, that the redshift was a mini, kind of like a mini boss. Like once you figure out the mini boss, you can do the next set of puzzles. So thank you for joining me. If you want to keep up with all of our gimmicks, jump over to I keep doing that. Jump over to Instagram. Oh my god. Jump over to Instagram at pint.party. That's where like we post when we go live, and we post gimmicks and stuff. Tomorrow as well is new podcast day, Tuesday. New episode of Pint Party's coming out, and oh boy, is it a good one. Well, it's good in the fact that like it was like between being cold and being at home, I finally like kind of went crazy, and that kind of shows in that episode of Pint Party. So you can listen to me kind of like, you know, spiral into madness. Well, it's a combination of things. It's being cold, being at home, and like being defeated from that last Exapunks puzzle. So like the three of them, like my brain was just like, and you can hear that on display. And then we also get into some topics, like we talk a little bit of sport. We talk about, you know, also we talk sport. We talk fashion. I think we do, and I think that's it. Yeah, no, I think that's the entire episode. Me going insane, talking sport, talking fashion. That's the whole episode. So check that out. It's on Spotify. It's on Apple Podcasts. It's everywhere you like to listen to podcasts, so you can check it out there. The link to the podcast is just down below. Also, if you want to catch up on previous broadcasts, like if you want to see what I'm referring to with like other puzzles and stuff, or if you want to see like my brain break in like watch that happen in real time. If you freeze frame, you can see the exact moment his brain breaks. All of those are in a playlist on YouTube, except for actually that video won't come out for a couple of days. So that specific video isn't going to come out until Wednesday. So not tomorrow, day after tomorrow. But when it does, it'll come out. I just rendered it out, so I'm gonna upload that and schedule it to come out on Wednesday, because tomorrow's podcast day, and that's where the podcast is. And there's a link to our YouTube channel below as well, and that's where all our stream archives are, as well as the podcast as well. So if you prefer to listen to your podcasts on YouTube, all the podcasts are there. So by all means, like tune in to check out our YouTube channel tomorrow, and there'll be a fresh new episode of Pint Party there ready for you. And I think that's all I needed to say. Yeah. Okay. Right. Cool. Yeah. I think that's it. I think I've covered everything. Yeah. Instagram. Oh yeah. If you like this as well, like be sure to follow us on Instagram to get updated. But also you can follow us on Twitch as well, because that's another easy way of knowing when I go live and stream. I think that's it. Yeah. I think that's now everything covered. Cool. Well. This has been Pint Party. Cheers.